Why is logistic regression important? Predicting whether a customer buys or not, estimating if a student will pass or fail a test, deciding if it is going to rain or stay sunny. Example, will the dog chase the ball? Meet Max the dog. When you throw a ball, sometimes Max chases it, and sometimes he doesn't. How can we predict if Max will run after it? Factors we consider: Max mood, excited or tired, the distance of the throw, and whether it is sunny outside. Logistic regression predicts yes or no. Logistic regression is all about predicting two possible outcomes, yes or no, buy or not, win or loss. We call this a binary outcome. Example, predicting if you will like a movie, yes or no. How does logistic regression work? Imagine a seesaw. On one side, we have all the things that make an outcome likely to happen. On the other side, things that don't. Logistic regression finds a balance and decides if the seesaw tips towards yes or no. The magic formula, but don't worry about the math. Logistic regression uses a special formula that takes different factors and turns them into a probability, a number between 0 and 1. If the probability is high, close to 1, we predict yes. If it is low, close to 0, we predict no. Predicting if a customer will buy. We look at how many emails they opened, whether they clicked a link, and their purchase history. Logistic regression helps us combine all this to estimate whether they will buy. How sure are we? Logistic regression gives us a probability. For instance, it might say there is a 70% chance this customer will make a purchase. We can use this to make decisions. How is logistic regression different from linear regression? Linear regression predicts numbers, example sales, temperature. Logistic regression predicts yes or no outcomes. Let's predict in Excel. We will use Excel solver tool to predict whether customers will buy or not. No coding needed, just a bit of spreadsheet magic. Why is logistic regression so cool? Helps you make better decisions based on data, not guesses. Can be applied in business, health, sports, and more. It's simple, powerful, and anyone can do it with Excel. Ready to predict the future? Get excited because next we will use real data to predict and make decisions. Stay curious and let's dive into the next part together. Introducing the logistic regression formula. The logistic function helps us predict a yes or no outcome, like whether a customer will buy something. The formula looks like this. 1 over 1 plus e to the power of minus b0 plus b1 times x1 plus b2 times x2 plus bn times xn. Don't worry, it is simpler than it looks. It just helps us find a probability between 0 and 1. Breaking down the formula in simple terms. So in this formula, P is the predicted probability chance that something will happen. B0, B1, B2, and so on are the weights that show how important each factor is. X1 and X2 are inputs like emails opened or clicks made. The formula turns all of this into a value between 0 and 1, like a probability meter. Imagine a seesaw with different weights. It helps us decide if we lean towards yes or no. What is log loss? Log loss measures how well our model's prediction match the actual outcomes. It tells us how confident our predictions are and penalizes wrong predictions more heavily. The log loss formula is L equal to minus y times ln p plus 1 minus y times ln 1 minus p. So where L is the log loss value for one observation, y is the actual outcome 1 or 0, p is the predicted probability of outcome being 1 between 0 and 1. Ln is the natural logarithm. Breaking down the log loss formula. When y equal to 1, log loss equal to minus ln p. If p is close to 1, log loss is low, good prediction. If p is low, log loss is high, bad prediction. When y equal to 0, log loss equal to minus ln of 1 minus p. If p is close to 0, log loss is low, good prediction. If p is high, log loss is high, bad prediction. When y equal to 1, these two conditions apply. When y equal to 0, these two conditions apply. Log loss penalizes incorrect predictions more if the model is confident but wrong. If the model predicts with high confidence and is wrong, the log loss is very high. If the model is correct and confident, the log loss is very low. Our goal is to minimize the total log loss across all observations, and that can be done using solver. Example, predicting purchase. Customer A actual equal to 1, predicted P equal to 0.9. Log loss equal to minus ln 0.9 equal to 0.105. Low log loss, that means good prediction. Since the actual is 1, which is very close to the predicted P equal to 0.9, it's a good prediction. Customer B actual equal to 0, means the customer didn't purchase. It was predicted with 80% chance that the customer will buy it, although actually it's 0. So in this case, the log loss is very high, 1.609. So high log loss means poor prediction. So this value here, 1.609, if you notice, is much higher than 0.105. And low log loss is good, means good prediction, and high log loss is bad, means poor prediction. And our target is to minimize the log loss. Now let's say a scenario. Imagine you work for a retail store and you have recently run a marketing campaign targeting a group of customers. You want to predict whether a customer will make a purchase based on their interactions with your campaign. You have data on several factors like how many emails a customer opened, whether they clicked a link in those emails, and their previous purchase history. Your goal is to use logistic regression to predict the likelihood of a customer making a purchase after receiving the marketing material. This kind of prediction helps the store make better decisions on how to allocate its marketing budget and which customers are most likely to respond to offers. Objective is to predict the probability that a customer will make a purchase based on data from a marketing campaign. We will use Excel solver tool to estimate the parameters of the logistic regression model.